Hi, my name is John. I'm an undergraduate physics major here at the University of Maryland, College Park, and I'm excited to demonstrate for you our capacitor demo. So I've got three objects here in front of me. This is our capacitor, this is our 67.5 volt camping battery, and this is our old school screwdriver. So to set this up, I'm going to take our camping battery here, which has a positive and a negative terminal, and I'm going to place its contacts on both of the contacts on either side of the capacitor and count to 10. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now is the time for you to try and guess at home what you think is going to happen when I use my dear screwdriver friend here to bridge the terminals. Here we go. Woo! So a capacitor is a type of electronic component that is very simple but astoundingly important. I don't think there's a single piece of modern electronics that doesn't take advantage of a device like this. So what really is it? So a capacitor can fundamentally be thought of as just a pair of parallel plates that are separated by some insulating material. So when I use my battery to apply a voltage across these two plates, charges from the battery begin to flow into either side of the capacitor, trying to find a path through which to complete the circuit. But in doing so, they encounter this insulating material between either plate of the capacitor, and so charges begin to build up. In this case, we have negative charges on this side and positive charges on this side. And these negative and positive charges form an electric field that is in the middle of our capacitor. And that electric field is storing energy. So then when I disconnect the battery, those charges stay in place because they're attracted to one another, and there's no other place for them to go. And so then, when I use my screwdriver to bridge the two terminals of the capacitor, I'm creating a new short circuit that allows the charges to now have a conductive path to reconnect. And in doing so, I release all of that energy almost instantaneously. That gives us that nice big bang as we complete the circuit. So something for you to think about to try and understand what's different between a capacitor and a battery is what happens if I bridge the terminals of the battery with the screwdriver. When I bridge the terminals of the capacitor, I got a big bang. But our phones, the batteries that we encounter in our everyday lives generally don't give off discharges like this. So I'll give you a moment now to take a guess what happens when I do this, and then I'll show you in just a second. The answer is absolutely nothing. Because a battery stores energy in a fundamentally different way from a capacitor. In a capacitor, we're storing energy in a purely electric form. Charges build up on either plate, and all of that energy is in the electric field. And so as soon as I create a conductive path, it all disappears as quickly as possible. Whereas in the case of a battery, all of my energy is stored chemically, and it's released slowly through chemical reactions that are occurring inside of the battery. So even if I create a path, current is flowing, but it's not flowing nearly as quickly as when I release it from a capacitor. So this is why our phones aren't powered by capacitors. Although they're very efficient energy storage units, they release it all at once, so you'd have to charge your phone every time you opened it up.